Today's lesson is on covalent bonds and naming. So why do atoms bond? It's all about gaining stability. Atoms are most stable when their outermost electron shell is filled. We've talked about that before, that they like to have a completely filled shell, whether that involves adding electrons or subtracting them in an ionic bond, or in what we're going to see here in a moment, covalent bonding is sharing them. For ionic bonds, this involves gaining or losing electrons to form ions. If you recall from our worksheet from section 3, we would add or subtract electrons from the shells to either fill the shell or remove it so that the inner shell would be exposed, that would be completely filled. Okay, so that's what we were doing there, but that was for ionic bonds, right, and for ionic compounds. Ions are the same electron diagrams as their closest noble gas, right? That's what they were trying to do. From the octet rule, atoms with 8 valence electrons are most stable, and there it's also going to be what we are trying to do with these covalent substances. Sharing is another way to obtain a valence shell of 8 electrons. A covalent bond is a chemical bond that results from sharing valence electrons. So this is sharing, okay? Just for reference, ionic, okay, that is gaining or losing electrons. Covalent is sharing electrons, so they're not physically giving it up or taking an electron, they're sharing them. There's a special name for compounds that form from sharing valence electrons, and that is molecule. A molecule is formed when 2 or more atoms bond covalently. So you cannot call something like sodium chloride, okay, which is an ionic compound, a molecule. Okay, molecules apply to things that are strictly covalent. So like water, H2O, there's no metals in that. That is a molecule, one molecule of water. The shared electron becomes part of both atoms' outermost shells, and covalent bonds form only between nonmetals. This is an important point. There are 2 naming systems. In section 5, we talked about the ionic naming system. Okay, and that was for your ion sheet. This is a metal plus a nonmetal, and if you recall, the only exception to that metal there would be an ammonium ion. Okay, section 6, which is the one we're doing here today, is strictly for covalent naming. Okay, and this is with multiple nonmetals. Okay, so these rules are separate rules. They're not going to be using your ion sheet. Okay, do not use ion sheet. These are not ionic compounds, these are covalent compounds. So these are a separate set of rules. They're very easy, okay, but don't try to confuse the two. All right, make sure we use ionic rules for ionic and covalent rules for covalent. We know which one is which because it's ionic if it's a metal and a nonmetal. It's covalent if it's just non-metals. That's how we know the difference. Apply the ionic naming in this situation, covalent naming in this situation. Some elements actually do not exist as simply a single atom, and we're going to see a few of them here. They are all going to be nonmetals. We call these diatomic molecules, so they don't exist as just a single atom of that element. They're always bonded to themselves. This is because they want to fill their valence shells. There's a list here of diatomic molecules. You will need to know these. They always come, if they are as an element, they always come bound to themselves. All right, and this list starts with hydrogen. It's H2. Nitrogen is always N2. Oxygen is always O2 as an element. Next one is fluorine, F2. Chlorine gas is Cl2. Liquid bromine is Br2. And solid iodine is I2. Okay? And if you're trying to remember where exactly those are on the table, hydrogen's kind of by itself on the top left. And then the rest of these kind of form like an upside down L Tetris piece right on the other side of the table. So this is the left side of the periodic table. There's hydrogen up there. And then the rest of these form kind of an upside down L Tetris piece Okay, that's kind of my way of remembering which ones they are. H2, N2, O2, F2, Cl2, Br2, and I2. Okay, that's the list. So if we're talking about elemental iodine, it's not just I, it's I2. If we're talking about elemental oxygen, it's not just O, but O2. You'll need to know this list later on this year when we are converting statements from something like, say, methane plus oxygen gas reacts to form carbon dioxide and water. Well, oxygen gas is not just O, it's O2. Okay, so these always exist if they're as an element bound to themselves. In compounds, we can obviously have numbers other than just, right, 1 or 2. We can have different ones there, but as elements, they have to be bound to themselves. Okay, so the naming rules for molecular compounds, for molecules, right? Okay, so this is for section 3.6, right? We do not use an ion sheet. We use these 3 rules, and they're very, very simple. And I think you guys will actually find this even easier than the ionic naming. But do not confuse the 2. So, rule number 1, we're going to use N2O as an example here in just a minute. Rule number 1, the first element in the formula is always named first using the entire element's name. So we'll pick, the first one here, which is nitrogen. The second element in the formula is named using its root and adding the suffix "ide." So the second element here is oxygen, so changing the suffix and keeping the root, we would have oxide. And then number 3 is to add the correct prefixes based on the number of each atom, which we will see here in just a moment. But there's prefixes. They are for the Greek prefixes as numbers, which we will see here in just a sec. Okay, so here are the prefixes. This is step 3 when we have to add prefixes to the naming. The prefix for number 1 is mono, 2 is di, 3 tri, 4 is tetra. That's usually one that gets messed up. It's not quad or quadro or quadra or anything like that. 5 is penta, 6 hexa, 7 hepta. That's another one that's often missed. 8 is octa, 9 is nona, 10 is deca. Okay, so these are prefixes that we are going to put in front of the naming. So we're going to take all of this and put it towards naming that N2O. But first, make sure you got this table in your notes, and you need to know these prefixes. Okay, so section 5, I'll let you use the ion sheet when naming ionic compounds, but for this one, you need to know these 10 prefixes. Most of them are pretty straightforward. You probably can guess penta is 5, and hexa is 6, and octa is 8, and probably even deca being 10. There's a few of them, though, that stand out as being a little bit unpredictable. Right? Tetra, hepta, nona, ones you haven't seen before. So make sure you know those. Okay, so putting this all together then, how do we name covalent substances? So N2O. All right, rule 1 said, name the first element, just naming the element. Well, the first element there is nitrogen. Okay, so that's what we got right there. So that was step 1. Okay, step 2 was to name the second element, take the root of it, and change the suffix to "ide." Okay, so step 2, that oxygen becomes oxide. So we have, up to this point, nitrogen oxide. Okay. Step 3 is to add prefixes. Well, we go and look at this one. There are 2 nitrogens, and if you flip back to the prefixes just a moment ago, the prefix for 2 is di. So we call this dinitrogen. And the prefix for 1, there's only 1 oxygen here, is mono. Now, instead of saying monoxide, they kind of shorten this. They cut it into monoxide. So we don't say dinitrogen monoxide. You'd say dinitrogen monoxide. But that's how we name it. So you just name the first element as is. Second element, the suffix becomes "ide." And then we put the correct prefixes in front of either the first or second element. There are a couple of small things just to be mindful of. The first one is that this example here, CO. Okay, if we name the first element carbon and the second one oxygen becoming oxide, okay, you'd be tempted to put, well, monoxide, and since there's 1 carbon, monocarbon monoxide. We do not put mono in front of the first element. Okay, so if the first element is 1, if the first element is first element is 1, do not include mono. We don't call it monocarbon monoxide. You've probably heard of carbon monoxide. That's what that is. Okay, so the first one doesn't have a prefix. It's assumed to be 1. There are a few of them down here that I do want you to actually kind of know that there are common names for. NH3, I'll write it over here to give myself a little space. NH3 by our naming system here would be nitrogen trihydride, changing the second element's suffix to "ide", hydride, and there's 3 of them, trihydride. The common name for that, and this one you should know, is ammonia. So if you ever hear me use ammonia, it is NH3. Another one, this is just kind of a fun one, N2H4. Okay, that naming system would give us dinitrogen tetrahydride. That one's got a name hydrazine. That is rocket fuel is what that is. Okay. All right, so we're going to practice here for a few of these, and then you can try a few on your worksheet. As a reminder, okay, for section 6, you do not use your ion sheet. The ion sheet is for ionic compounds. That was stuff out of section 3.5. That would be a metal plus a nonmetal. Everything here, okay, all of it is nonmetals. So we're going to use covalent naming, all right? So this first one, CO2, the first element is carbon. Second element is oxygen. We're going to change it to oxide. The suffix becomes "ide." And there's only 1 carbon. We're not going to put monocarbon, again, because if the first element is 1, we do not write mono. I have 2 oxygens, so that is dioxide. So carbon dioxide, a gas you've probably heard of, that's how it gets its name, is from this system. Okay, carbon dioxide. The second one here is going to sound fairly similar. First element is sulfur. Again, it's oxygen as the second element. The suffix becomes "ide." I only have 1 sulfur. I do not write monosulfur, just sulfur. And then the prefix in front of oxide should be di, because there are 2 of them. So that's just sulfur dioxide. NF3, name the first element, nitrogen. Second element is fluorine. We're going to change the suffix to "ide", so it's fluoride. And this time my prefix is 3 for fluoride, so it's going to be trifluoride, nitrogen trifluoride. CCl4, first element is carbon. Second element is chlorine. We change the suffix to "ide", so chloride. I only have 1 carbon. I don't write monocarbon as the first part there. But Cl has 4, so this is going to be tetrachloride, carbon tetrachloride. Last example here, N2F4. First element is nitrogen. Second element is fluorine, so that'll be fluoride. Change the suffix to "ide". This time I do have something other than just 1 of my first element. So this would be dinitrogen, and the 4 for fluoride would be tetrafluoride, dinitrogen tetrafluoride. And that's it.